Hi guys, this is lesson 3 in unit 4. We're going to talk about solving system of equations using elimination. Let's take a look at this example that we have here. We have a system of two equations, x plus 2y equals 14 and negative x minus 3y equals negative 9. The first question that we have to ask ourselves to be able to solve by elimination is, do we have additive inverses in both equations? And you guys remember that additive inverses are numbers or variables that can be added together to cancel each other. So 2 and negative 2, 3 and negative 3, and in this case it's x and negative x. Now that we know that we have additive inverses, what we need to do is to add both equations to each other to eliminate the inverses, which means I need to add the first equation to the second equation because that's going to help me have an equation in one variable. So let's take a look at how this can happen. I'm going to add x to negative x. These two are going to cancel each other. I'm going to end up with 0. And then I'm going to add 2y to negative 3y, and I'm going to end up with negative y. And then I'm going to add 14 to negative 9, and that answer is 5. Now we end up with an equation in just one variable, which is y in this case. So all I need to do is to solve this one-step equation to find the value of y. So looking at this equation, the only thing I need to do is to divide both variables by negative 1. This will lead to y equals negative 5. So negative 5 is the first part of the solution, which is the y coordinate. And now all I need to do is to find the second part of the solution, which is the x coordinate. So now I need to find the value of x by substituting the value of y in one of the equations, and it doesn't matter which equation you use. So I have the value of y in here, which is negative 5. So I'm going to substitute negative 5 for y, and then I'm going to solve the equation, which is an equation in one variable. So I'm going to end up with x plus negative 10 equals 14, and this is a one-step equation. I can isolate the x by adding 10 to both sides, and then I'm going to end up with x equals 24. So 24 is the x coordinate of the solution. So the solution for this system now is 24, negative 5. Now that I know that my solution is 24, negative 5, all I need to do is to check and find out if my answer is correct. So this time I'm going to use the other equation in the system. So usually you substitute in one equation and you check in the second equation. So in this case, I'm going to have to substitute the value of x and y with 24 and negative 5, which is going to make me end with negative 24 plus 15 equals negative 9, and then negative 9 equal to negative 9, which is a true statement. This tells me that my or the solution that I got by solving using elimination is correct, and that's the right solution for this system.